Okay, let's look at this example then. It's another one of those questions where I take my time extracting the information from the question. So it says, car whose engine emits a noise of frequency 500 hertz is traveling towards a stationary observer at 20 meters per second. The speed of sound there is 340 meters per second. Calculate the frequency and wavelength detected by the stationary observer. So it says car engine emits a noise. So that is the initial frequency really that it's emitted at normally. So that's our 500 hertz. That's not going to be the frequency that our stationary observer detects because the car is moving. So our speed of our source is 20 meters per second. But the key thing to remember here is it's traveling towards the stationary observer, and if the velocity is moving towards the stationary observer, we need to make sure it's negative. The velocity of the wave itself is 340 meters per second, and the first thing we're going to find out is the frequency that the stationary observer would detect. First thing we do is write out the equation we're going to use. We then put in our values, so f, that would equal the velocity of the wave, divided by the velocity of the wave plus the velocity of the source, but that is minus 20, times our frequency, which is 500. Type that into your calculator. And we get that it is 531 hertz. Once you get to that point, stop and think, does that make sense? Would you expect the observer to be detecting a higher frequency? Yes, because the car is moving towards it, we're going to get a higher frequency. If it comes out that we got a lower frequency, we would expect a higher frequency. I would go back and check that your positives and negatives are the right way around for the velocity of the source. Next thing we have to do is calculate the wavelength. Now we can then use this equation here to do that. However, we're really making our life more difficult than it needs to be. We've already got the frequency here. Therefore, I would just do V equals F lambda, and velocity we're told is 340 equals 531 times lambda 340 divided by 531 gives us our wavelength. Once again, type that into our calculator, and it gives us 0.64. So wavelength, so meters. Okay, now I try the questions from the textbook below, and I'll post a little video of the solutions to them. Do try the questions yourselves, please.